Now we're going to study in more detail how catalysts actually work. And there's two theories with catalyst action: surface adsorption and intermediate formation. So let's look at first at surface adsorption. Now first understand the term adsorption. So adsorption is very different to absorption. So when something absorbs, it goes from one area to the other. Adsorption, I want you to think of it, if you want to think of this or write it down, it sits on the surface. So imagine you're using very thick cream on your body, okay, and it doesn't absorb, it adsorbs. It doesn't go through, it doesn't sink into your skin, it sits on a layer on top. So surface adsorption is when we get a solid catalyst and the particles of a liquid or gas sits on top of the surface of the solid. So if we go back very briefly to our, when we were looking at concentration here, imagine if we had something that was low concentration and we had these very few particles, okay, and because they're so far apart, there's less chance of them bumping into one another, okay. No bumping into one another means no collisions, which means no reaction. But say if we could gather all those wee particles into the one small area and contain them within the one small area, there would be a greater chance of them colliding with each other, i.e. reacting. And that's essentially what surface adsorption is about. So say we had the solid catalyst. Right, and I'll just draw a box around that to make it solid. What we're doing now is we're going to capture all the liquid or gaseous particles and they're going to sit on top of the surface of our solid catalyst. Now we have them contained in one area. Because they're now contained within one area, they're going to increase the frequency of collisions, which increases the rate of reaction. So that's how the catalyst in this surface adsorption theory works. So it's also described as heterogeneous catalysis. Right? Hetero means different. Right? So the catalyst is in a different state than the reactant, and it's typically a solid reactant plus a liquid or gaseous solid, I should say, catalyst, excuse me, and a liquid or gaseous reactant. So the particles of the liquid or gaseous reactant sits on top of the surface of our solid catalyst, and that increases the frequency of collisions, which increases the rate of reaction.